time? Okay. Okay. Right, so my name's Damion Dooley, and I work under grant money from the University of British Columbia, and have been involved for the last 3 years in genomic epidemiology and ontology, the connection between the two. So today I wanted to introduce you folks to ontologies and show how they are a vehicle for managing this terminology that Jeff and others have talked about rolling into the future. First short question, how many of you in being confronted with a medical term have used an ontology lookup service to see what might have been defined within the ontology community? If I could just see a raise of hands. Okay, great. So this is a good talk for you guys. So starting here, it's just amazing how much genomic sequencing has made a difference in terms of public health, and how the technology is starting to coalesce and stabilize and give reliable results. My experience with this is through the IRIDA.ca project, rapid enteric sequencing of foodborne pathogens. And that project for the last 3 years has created one of these options out in the world right now to sequence your data and to give you phylogenetic and SNP and taxonomy results for your data sets. Now, the contextual part of the information that's riding alongside these sequences, however, is not stabilized. There are some ontologies like SNOMED and MESH that seek to describe the whole domain of terminology out there that's pertinent to medical science, but really when you take a look at the databases within particular institutions, unless they happen to be using the same software as each other, it's very hard for them to share software. And when it comes to software, people developing user interfaces, there's nothing to pluck from the world to incorporate into your own software and forms. And so one of the solutions that's popped up in the last 10 years to address this problem of varying terminology out there is the ontology world, and specifically OWL ontologies, which seek basically to define on online resources the official label of a term, the synonyms for that term, a plain English definition for that term, and then a logical underpinning, an actual computer-readable format in XML or RDF of the relations between that term and its hierarchic structure, like a taxonomy of animals and plants and NCBI, or a plant ontology that's specializing in the molecular structure and processes, chemical processes of plants. So one of the collections, open source communities that have coalesced together to describe terms within the biomedical community is the Obo Foundry group. And so if you go to that website, you'll go and see ontologies that are trying to orthogonally work on particular more narrow domains of medical terminology. So we've got one for taxonomy, one for chemicals of biological interest. The Go ontology is the most famous one that's seen success in all sorts of academic genomics research. These ontologies are operating kind of in a competitive environment that's a lot like the age of dictionaries. We're in the age of print. I'm saying that ontologies are in the digital age what dictionary creation was doing 100 years ago. So I'll just give you a little insight into what it's like to develop an ontology resource for your own organization, your own project or software. Often the pattern is that you go out into the world of terms to see what's available, use a search engine, and see if your terms are available. If they are, then you'll get a list of IDs, unique IDs globally that refer to that term. You can put them together in a file, use an online resource like Ontofox, and get back an XML file that includes the term, its definition, its label. And then you can turn to a resource like Protégé to take those files in and give you a little bit more of a readable presentation of that material. The other thing about these ontologies, OWL ontologies, is that they are multilingual. So if you are trying to approach internationally usable software, not only can the languages of each term and definition be in English, but you can also have people curate other language versions of the tools. But what we're also seeing down here is the logic engine, logical part of it all, where you get to define, with respect to other terms within your own ontology or other partner ontologies, what your term means in a bit more of a formal semantic way, using formal logic, actually, that reasoners can pour through to make deductions. So it's a combination of this population census item being within a hierarchy of other terms that allow us to know that a population census has some value, it's a count of things, it's about some population, and it actually pertains to some Earth area boundary. So what we're looking for in the ontology community is that the more you add a logical layer onto the definitions of these terms, the more information starts flowing out of them. And we're hoping that we can attach ontology-driven descriptions into query engines that can then go ask query databases online. So the last step, of course, is to publish your ontology back to a foundry, and there are a number of, or an ontology lookup resource, and there are a number of them out there. So specifically, the ontology I've been focusing on for the last year and a half is called Genepio, and it's to ride alongside the IRIDA software. That's its first goal in describing lab analytics, the different kinds of traditional tests alongside genomic tests, the patient demographics, some metadata around cases, sample metadata in the case where a person isn't involved directly, but maybe a food is involved, or you're sampling livestock at a farm, you're sampling manure, and some terms around the epidemiology investigation, because we're interested in presenting all of this information back to epidemiologists. But I should, mention that. So let's just take a peek at what an investigation looks like, and then you'll see the variety of ontologies I've had to pull in to help describe this domain. So you're starting with the sample that came from a case. Could be from food, a swab. You're getting an isolate out of it. Sequencing and testing happens, so we're able to carry on an identification process, and then the variation, which leads to phylogeny. And that circles back, because now we can start comparing the phylogeny and other metadata, clinical and other data around the host that was involved in this case. All of this is pertaining to human beings, but it's also pertaining to animals. We have partners in the project who are very interested in the diseases of tuberculosis and others that move through livestock. And so we're trying to adapt the terminology so that it's not just human-centric. So these are the different ontologies I had to pluck from. Uberon, anatomy ontology, human phenotype, different kinds of diseases in DOID, over 2,000 topical terms, and this is just a little quick example of what they look like in Protégé, the different hierarchies of terms that we're bringing in. So, naturally there are problems with the world of use from continent to continent, from one side of Canada to the other. People can use different words to mean different things, and the comedians have known about this for years. They make a lot of mileage out of it. A case in point is the ranking of a patient's medical condition, the quality of healthiness. The American Hospital Association says if you talk to the press, you have to use one of these terms. You're allowed to use one of those terms to describe to the press a condition of somebody in a hospital. Over on the other side of the Atlantic, you've got a whole other set of terms that are recommended within their health system. So this is one example of the kind of issue in ontology, just like regular database business that you always run into. But the difference here is that maybe we're publishing the solution to this online so that everybody can reuse that and not have to deal with the mishmash thing, handing it over to their software people or others. So that is one aspect. Genepio wants to actually talk to these different A, databases, and B, standards to know what's in them. Yeah, a database, in a way, from a certain provider is just like a standard, just from their point of view. So the first aim is to enable sequences to be described and sent into NCBI for biosample and bioproject. And there's metadata associated with that, not just the sequencing information. But since we're trying to meet different standards, what we're coming up with is a general concept, subject age at time of specimen collection in this case, and we're listing off and making it a subclass of these different standards, everything from NCBI biosample to a Mixus minimum set of descriptive terms, PulseNet data item. Guess what? A lot of these databases, these standards have different names for the terms. So we need to detail that if we're going to try to be compatible and allow data to move between these sources. So we're getting into the business of describing what their vision of the term is and their definition and label, which may be a little bit different on the surface. Over here, I'm just showing an example of how we can make reference to this field within a form of different fields. TB case subject characteristics, here's the metadata that we're looking at incorporating. And what we really want to do is see what this stuff looks like in an actual web form. So this is exploring the distance between the ontology folks, the technologists, and the end users who need to give feedback about what these terms are and whether they're actually accurate, whether we have the definitions right. So that is because we're trying to encourage the repurposing of this ontology terminology out, not just to academic projects, but also to industry and government. There's so many software developers out there who are just crying for vocabularies that are globally accepted so that they can list off country and sexuality and other traits on their medical forms without having to worry that they're creating data conflicts. So the reuse, this technology though is still kind of rare outside of academia because of the formal logic level to understand it is so intense that you'd have to have a master's degree or doctorate in formal logic to really be at the heart of that community. And the software people find that they actually have to write a lot of software, even if they take the time, the year or two, to understand it all. So what we're trying to provide is, in our ontology, is a model of what our different users need. And so we've got a few models lifted off here, and one of them is the Mycobacterium tuberculosis model, and this is fresh off the printing press because we're closer to this one than we have been to our other work. In other words, it's just been in the last year that we've started to engage with the tuberculosis community and learn about what kind of fields you folks need and what your model is for it. So this interface, which I'm going to show you, is allowing you to browse the different models and then actually see the forms in them that list off all of the different parts, data parts, as the ontology represents them under the hood. And we want to add some nifty things. Right now, this is a mock-up. This is a mock-up showing what we're calling a proof sheet, just to allow us to interact with epidemiologists and other end users of the terminology. So it's got certain functionality there, including things like ability to select your units that we know are acceptable, and a bunch of other bells and whistles, which I won't have time to go into. But what we're heading for is, can I click it? Sorry, it's not actually going forward. Anyway, what we're heading for is tools to allow software people to download the entity specifications to go online and order up the parts that they need for their experiment or database system, and to download those specs and so themselves be able to generate the forms and inputs. That's one aim for the project, funded in the next year and a half, and the other aim is to actually build a tool to go ahead and actually translate the data from one data source to another. So pet project would be the RefSeq to NCBI biosample translation. Now maybe somebody's already done that out there. My first time exposing myself to the RefSeq folks here, so I'm hoping to learn a lot more about that. So all this opens up, I think, a plug-and-play future where you can have a ontology specification, in this case, BC Vancouver Coastal Health Association, and know that because it is located in some Earth's surface, because it has a 2D boundary, that it has an Earth area census, population census, it has a name, and from that you can locate it on the planet and get GIS maps out of it and cross-reference to census data and generate nice graphs much more easily than we can right now. But that's into the future. The last thing to say is that by defining certain ontology terms, we're actually able to describe their content so specifically that I'm expecting that these will actually be able to be plug-and-play software components into the future. You'll order up a formula. This formula name is, where is it? Hill equation. It actually has a representation, and that's it being rendered on the screen, but this is enough information to actually perform math on it. So you can just imagine bringing these things into your own software spreadsheets. Last thing to say, we're developing a consortium around Genepio to push it out. Lots of different organizations we're getting input from and trying to make sure we're compatible with and aware of their needs. And this is the acknowledgements for the project, including thanks to the Oxford TB folks, CPAD, and British Columbia Center for Disease Control. So thanks for your time.